Good evening, Professor Murphy. My name is Jason Fernandez, and in this video, I will show gameplay of my solo project called New Metal City. And later on in the video, we're going to have a discussion on the code, so you can better understand how the game works. So for my solo project, I decided to go with a tank style game from the bird's eye view. Um, I kind of wanted it to be based on this game that I used to play back in the day when I was a kid. This is called Battle City. It's on the Nintendo Entertainment System, and pretty much what this game is about is you control a tank. It's taking me to the link. So basically, you control a tank, and you have to defend like a certain statue that's located somewhere in the map, and you have to defend it from different enemy tanks that spawn at random locations, and they're gonna try to shoot the statue down. And once they shoot that statue down, the game is up. And I think in this game you have like a limited amount of lives too. So either if the statue gets shot down or you die, the game ends. When you lose all your lives, I meant to say. But and as you can see right here in the UI, you have to pretty much just shoot down all the enemies in the level in order to advance to the next level. And as levels progress, the structure of the map changes, positioning of the bricks change as well. You can shoot down the bricks on here. Um, but that's what I wanted my project to be based on. It's not a exact copy, but as you play the game, um, it's gonna feel like playing that game on the NES. But I had to rename it so I won't have to get hit with a copyright strike or whatever. But let's get into the game. So right here, we have this title screen right here with the UI. You have two options. You can start the game or you can quit the game. Obviously, when you quit the game, select quit, and you press enter. It leaves the game. Let me just run it again to start it up. So obviously we're gonna wanna start the game. So before we get into the gameplay, just a quick review on the controls. So I set the arrow keys on the keyboard as the directional input. Um, I have the enter button set as the key to like select options like after levels or when you die, when you get sent back to the title screen. Enter is gonna be the key to select the option. Uh, so I have the directional inputs for moving the tank, and I also have the F key as the button to fire the bullet. So let's get into it right here. Let me pause. And you see right here, I have the UI for the pause screen. So I have P set to pause. If you want to pause the game, you can just press P. Um, not really any much else in terms of selecting options in the pause screen as of now. So as you can see here, so this is gonna be the tank that you're gonna be controlling. This is I want to say olive green tank. This is gonna be the tank that you're gonna be controlling, and the objective of the game is to try to kill these three other tanks so you can be able to advance to the next level. And then in this game, we have a total of 4 levels. This is the first level, and after every level, the structure of the map changes. The positioning of the walls in the map is going to change, as well as the positioning of the health packs, as you can see here. So each health pack, if I remember correctly, brings back 50% of your health. Um, and if you're already full of health, you're not gonna be able to pick up the health pack. So you can see the health bars right here. This timer right here, I kind of left it because for the group project in which I was not able to complete with my group members. I wanted to have the timer right here so I could be able to implement the code from here over to the group project. But since that didn't come into fruition, I just kind of left it there. I forgot about it. But there's no timer. It's infinite time. But what you want to try to do is try to shoot down all three of these enemy tanks before they shoot you down. Obviously, when all of your health goes down, you lose the game. So just a little intro for the enemy tank. So this is you. This is the tank that you control right here. The second tank right here. So what I have for each enemy tank is they have like these special properties to them. So the light blue tank, he's the faster tank. He moves faster than all the other tanks in the game. However, there is a drawback. The bullet damage from this tank is less than from the other tanks in the game. The second tank right here, this is what I like to call the power tank. Now, the power tank has pretty much the same set speed, regular speed, same amount of health as you, just the normal amount of health. But what this tank is, the special thing about this tank, the special property that it has is that his bullets deal a lot more damage than all the other tanks in the game. So this has like the most powerful bullets in the game. So once you get hit with this tank, get ready to see your health go down by a lot. So that's the second tank. This is the red tank right here. This is the power tank. This is the speed tank. This is the power tank. And now we're going on to the last tank. The last tank right here is what I like to call the armor tank. So the armor tank, the dark blue tank is the armor tank. So basically, as the name implies, it has armor as the armor tank. It has more health than all the other tanks. Drawback being that it's slow. It's slower than the other tanks, significantly. As you're gonna see in the game right now. So, sorry. Um, anything else I need to discuss at the moment? All right, not at the moment. So we can have the game running. And if you can see in the bottom of the console, this is a little log thing that I have for the positioning of the player. So this is something that I wanted to test out when I was doing the controls for the player tank. So if when you see the player moving, you're gonna see all of these values for the X and Y coordinates change. So let's pause this. Let's get straight into the game. So as you can see here, I'm moving right, left, up, and down. And as you can see, these tanks are moving independently, and you can already see the speed tank is moving fast, it's moving quick. I'm moving at a set pace. The armor tank is moving slow, and the power tank is moving around the same speed as me. So let's have the speed tank try to kill me real quick. Okay, right there, and then the UI pops up. It says that I lost in all caps. So now you have the option whether to go back to the title screen to restart or quit. And this is a little thing about the game. The game doesn't have any checkpoints, so you can't start off from where you die off. So once you die, you die. You have to restart. But pretty much UI works the same as in the title screen. So we're gonna go back to the title screen. It takes me back to the title screen. We're gonna start again. So right here, I'm pressing F right now. You can see the bullets are. If I hit a wall, it's not gonna face through the wall. So so I added some collision detecting right here with the bullet and the walls. Um, so let's just try to see if we can pass the level. Um, okay, so that's one guy down. Now we're gonna try to get the armor tank. It's gonna take a minute because he has a lot of health. He's moving slow, as you can see. There we go. And gotta be careful with this guy. This guy packs a punch. And we kill them and we move on to level 2. And I added a little quote right here, let's rock, because that's what we're gonna do for the entirety of the game. So we go on to level 2. So begin. You press enter to continue, and you see that the structure of the map changes, as well as the positioning of the health packs. So we got to be careful with this guy right here, not get close, and then we got him. All right, moving on to the next. Okay, let me just get this guy here real quick. He's moving too quick. All right, let's worry about him for last. Let's get the armor tank right here. Okay, so we got him. Okay, and then we got it. So we move on to level 3. Map structure changes again. So let's try to get these guys going over here. Okay. Ooh, that packed a punch right there. Ooh, okay. So right here, I'm gonna get the health pack, and you see it in my health bar right here is a chunk of health has been gone. So we're gonna get the health pack, and we're gonna get our health back right here. So we could keep on going. Let's try to get these tanks out of the way. Okay. Oh, and we killed the guy. So we go over here, level 4. This is the last level right here, and me personally, I think this is kind of like it's kind of like a basic map design, but very unique at the same time. I think you might maybe like the design. I don't know, but let's move on. All right, so right here, this is the last level. I have the map designed to where, like, I pretty much kind of wanted like all the tanks to kind of like converge into the middle, you know. Uh, so right here, and instead of having 2 health packs, I only have 1 health pack for this level right here. So just to make the last level a little bit harder, um, right here, I got the armor tank. So this is gonna be, oh, this is gonna be interesting. Yeah, this this power tank packs a lot of a punch. That's why I'm moving with it with caution. So we beat the last level. On here on the UI it says you win. So again, you have 2 options: back to the title screen or you quit. But for to see more of the functionality of the game, we go back to the title screen, and takes us back to the title screen. We start the game, and then we start from level 1. Pretty straightforward. Basically, just to recap the objective, just try to kill the other enemy tanks as before all of your health goes down, and if that were to happen, then you would have to restart the game from the beginning. Okay, let me see, and I think that's pretty much it. Let me just okay, just so you can see, I'm gonna go on ahead. I'm gonna try to pass this first level, and then I'm gonna go on ahead and lose the second level. So you see that pretty much the game resets after loss. Ooh, okay. And then I'm going to get the health. There we go. Okay. So level 2. Let me go over to this power tank and let me go on ahead and let him kill me. Let me, if he wants me to pass. Okay, there we go. So back to title screen, and we're gonna start the game again. And you see we're back on level 1. So this is a pretty straightforward game. Did spend a lot of time, and I had to kind of like learn a little bit of new things outside of class to implement some stuff on here. And that's pretty much it for the demonstration. Hopefully, when you do have time, I hope that you'll be able to have time to give this a try. It's a pretty fun, straightforward game. Nothing too hard, nothing too complicated. It's pretty straightforward. Arrow keys for directions. The F key to fire your bullets. The P key to pause the game, and pressing enter to select the option. Excuse me. All right, so that's pretty much it for the game right now. Now I want to get into the actual code. Um, I know pretty much like I guess the majority of the class. I know that we were taught to try to use applet to do the graphics for the game, but since we were given the choice to do JFrame, I decided to pretty much like everybody else use JFrame on my game as well. I feel like it's simpler, it's more straightforward, and I feel like it's a little bit clearer than applet. Um, so when I was making the game, for some reason, like I'm doing it on my desktop now, but when I was making the code for the game, I was pretty much running the game on Java 7. Because for some reason, like on my laptop, Java 8 doesn't work well on my laptop. But since we're on my desktop right now, I kind of had to make some like little adjustments to get this running on Java 8 because that's a requirement for the class. So I got to run it on Java 8. Again, I had to make some adjustments, but we got the game up and running on here, and yeah. So right here, on this class right here for the game file, made this class, and this is gonna be pretty much the main thing that's gonna run the game right here. So right here, I wanted to set up the window. So it's actually a class JFrame for the game window. Put a new JFrame on there. Put up some options for the game window right here. For the game panel, which we're gonna get into a lot of detail later. This is where all the game stuff is happening. This is where I decided that all of the game's logic and all of the instantiations for the characters, tiles, and everything is gonna go into this file right here. But we'll get into that in a bit. So the game panel. This is the game panel that I was going to put into the game frame for the game window. Added it. Did the call some methods to help put the game into the window. Um, and we set the title of the game to New Metal City. Again, copyright. And we called the init method from the game panel. This is a method that we're gonna go into detail in a bit. So we're gonna go now into the game panel. All right. So the game panel. So this is gonna extend J panel. This is what's gonna go into the game window when we run the game. Implements the runnable and key listener interfaces. This is gonna be the interfaces that are gonna allow us to pretty much run the game, have the be able to have the NPCs moving around, have the player move around too. So right here for the values, this is for the screen. This is for the window. So I decided to go with a 16 by 16 pixel tile size of just overall. For the scale right here, we'll put it to 3 to try to convert it into a 48 for 48 to 48 for moderate resolution. For older devices, obviously. Not older. Well, what I meant to say was newer computers. I wanted to say, yeah. So this is gonna be the math for converting it into moderate resolution. Sorry. So right here, these two values right here, max column and max row. So basically, let me just run the game so I could better show you. So basically, this is gonna be I kind of wanted to measure out the window by the tile size. So right here, this is 25 tiles by 15. Is it 15? Yeah, 15. So 25 by 15. This is going to be the size of the window, and it's also going to be the size of the maps as well. So let me close it. Setting the screen resolution. So these values right here, they're going to be used for the size of the window. Screen width and screen height. It's pretty much the same thing that I was trying to explain. These were the values that are used, and they're gonna go in conjunction with the scale tile size and multiply it, and that's gonna give you pretty much the whole screen for the game. So right over here I have what's called game state variables, and pretty much these are like little integer values that once they change the state of the game. So right here, we initialize. We have the integer for the game state. We just leave it. Just declare without a value because these are going to be the values that are going to be put into the game state. So we have the value for the title screen. That's going to be 0. That's the initial game state for when the game starts. And then once you select the options to start the game state is going to change to play. Playing is going to be 1, and when you pause, press P and during playing the game, the game state is going to change into 2, which is going to be pause. When you beat the game, I mean when you beat the level, when you beat the level, game state is going to change into number 3, level change, and whether you win or lose the game state is going to change into 4, which is game over. And depending on whether you win or lose is going to be dependent on whether the player is still alive or not. That logic we're gonna get into later on into this video. So the level counter. This is its integer value that I've initialized. Just this is mostly for UI and for loading up the tile map for the level. This I'm gonna go into detail when I talk about the tile map and the UI. So just give me 1 second. Give me a sip of water. All right. So for what we learned in class, so in order to run what is called the game loop, we have to incorporate a thread, Java thread. So right here under the game variables, this is going to be a very important variable that we're going to declare. So we declare the thread object, so we can be able to have a thread that's going to run the game loop throughout the entirety of the game until it closes. Um, that we're gonna get into it a bit. It's gonna come up right now. We initialize the object of the tile map right here. Tile map, new tile map, and then let me just go into detail with the tile map right now. So going into the file. So for the tile map, so basically what the tile map is going to take the game panel, which is this main game panel that we have. Is going to take that as a parameter. Um, so I also incorporated a tile class as well. Let me get into this. So I did before I get into the detail, I did incorporate the direct class that was given to us during class. So this is going to be, I think, is going to be this class and 2 other classes that are going to inherit from the rec class. But this is the tile class. So what it has a image object of image that's going to be the image of the tile. that's going to be used. Whatever tile it may be, is going to have an ID. So when we run the tile map logic, it's going to load up the tiles onto the tile map according to the ID of the tile, and we have a boolean for solid. This is more for collision detection. Um, for collision detection with the tanks, the bullets. Um, so the constructor right here, again we inherit from rect. We call the super to create the tile onto the screen. Um, for the tile, you have to choose whether it could be solid or not solid. And then it's going to start out with the ID of 0. We initialize it to 0. Let me see. And then I made another constructor for creating the tile with the image name and the custom ID number that you want to put for the tile. So this right here, this constructor is going to try to pretty much get the resource, the image as a resource from this folder right here. The tiles. Let me go into the tiles. So it's gonna get either pretty much either one of these tiles. Not this one. This is more so for the background. It would be either this or either be the health pack or the wall break. Um, as you saw in the wall break is the darker um breaks that protruded out of the floor. Basically the wall. So we set the image to as I like to call it as the resource that we have in the tile. So we'll call it from this folder tiles. We get the image name, so it would either be the health red or wall brick. And since both of the images are PNG, we have a PNG at the end of the string. So this method is gonna get the file from there. And for this line of code to work, we do have to put into a try and catch. I haven't really put anything into the catch block because um, not really a lot of errors don't really happen as far as when I was testing it. So but if it does catch an error, then it would be best to just close the game as a whole. As I feel like it would be the right thing to do. And this parameter right here, that's going to set the whatever number you put. That's going to be the ID of the tile. Um, but the tiles, I think we declared it here. I'm pretty sure. No, right? Okay. No. Okay. So all of this tile stuff, this is going to be implemented right here into the tile map class. So we have an array of tiles, which is the types of tiles. We only have two at the moment. I made a 2D array for the map number. So basically, the map number is what's going to get the IDs for the tiles. If I remember correctly, this is no. Okay. So this 2D array is pretty much gonna grab the numbers from the levels. Let me just show you right here. Um, Let me see, level 1, level 2, level 3, level 4. So right here, these are just the custom text files that I have set for the levels. Level 1, level 2, level 3, and level 4. So just to kind of just make it simple. So what I have set here is for in terms of the IDs of the tiles. So I have it to where Zero is just a blank space. Nothing's there. All you can see in those locations is just the background and the level. Now, when you go to one, one is going to be set to the wall break tile. Let me go back to that one. It's going to be set to the wall break tile. And number two is the health pack. And all of these text files have the different locations for all of the tiles set. Obviously, we do want to set like boundaries around the level, so neither the player nor the enemy tanks leave the map. So all of these text files are going to have one around the whole matrix of numbers. So let me just close that for now. So these are the text files set for the levels. And once we run a certain function on here in the tile map class, which I'm gonna get to, um, it's going to take those numbers and then it's gonna put it into this 2D array that we're gonna call map num. So this is gonna be the numbers. It's gonna be the array for the numbers for the IDs. Um, then we make a tile array. What this is gonna be? This is gonna be the tile list. So what this is if I go into the code to make sure. Um, all right, so the tile list is basically like the list for the tiles that are going to be set onto the map when the certain tile map is called. And then the image right here that is set for the background. The background we already have it as the ground. That's gonna be the background for the tile map. In the constructor, we have the game panel and the level number set as the parameters. So pretty much if I were to put like one, it will load up the tile map for level one, two, tile map for level two, so on and so forth. Um, so for the types of tiles, I set it to 10. Um, it could be for the amount of tiles, it could have been two, but just to kind of like um because I made this class early, and I don't know if I wanted to have like different tiles like set throughout the map. But just to keep it I guess reasonable, I put it to 10 max for the tile array and the tile types. The map number. So basically, from the game panel right here, this is what I was talking about, the max columns and the max rows. This is going to set the 2D array to have that amount, max columns multiplied by the max row, and which is pretty much gonna set up. Let me see, which is pretty much gonna set up an array like this, like the tile map. And the tile list is pretty much the same thing. It's not gonna be a 2D array. It's just gonna be just a simple linear array, containing this amount of tiles in the list. Again, the try and catch to get the background as a resource from the folder. This is the file name tile ground, and then this function right here I'm gonna get into later. So change level right here. So this is a method that I'm going to be using in the game panel to change the level once the level changes, whether it changes onto the next level or it resets. So right here we call the load tiles and then we put level plus level number plus txt. So it's going to be like, you know, going through these level text files. So the load tile method, this is what's going to load the tiles onto the level. Sorry. So right here, this is going to um, put the input stream right here. Put an input stream object to try to get the level text files to load it from the source folder. And buffer reader is what's required to have the input stream working properly. We initialize these variables to zero because I'm gonna be running a while loop to try to iterate through the rows and the columns for the map. So while column is less than max column and row is less than max row. So right here, I have the read line method for the buffer reader initialized to this variable called line. That's pretty much going to read the numbers. This is what's going to read the run numbers from the text files. Run another while loop inside. Oh no, wait. Now I remember. The line of code that's going to read not the individual numbers but the line right here. This is what's going to read the line, and then it's gonna, as the while loop progresses, it's gonna keep going to each line until it gets to the end. So yeah, this is my apologies. This is this is for the entire line in the map class. So right here, we're running another while loop just to get iterate through the just to get iterate through this line column by column. Let me just leave this here for convenience. Um, so we're running the while loop for this line, and then it's going to have a string array. That's where the numbers are gonna go in. And then right here we use this split method to try to split the numbers off from these empty lines in between. And it's gonna get each and every string from after, like, before and after those splits. So right here for the number, so what we want to do is we wanted to call this method from the integer class to try to parse that string into an integer from this string array. And this is where we're gonna get back to the map num to the array. So for this one it's gonna be 0 0. So map num column, so it's gonna be map number 0 0. And then it's gonna be equal to the number. That's going to be the integer, not the string. And then after that we iterate to the other column. So after this is parsed, then we move on to the next, and then the next, and then the next, and then once this is finished, we move on to the next row. As you can see in this line right here, we increment the column variable. Once it gets to max column, we reset it to 0, so it goes back to the beginning. But this time we're gonna increment the row, so it goes down the row. And for best practice, we close the buffered reader after this little tile is done. Again, no errors are really expected as of now, so I haven't implemented any error handling into the methods. So this is kind of similar to the load tiles, except that this right here is going to create the physical tiles in the map. So for this is just loading the tiles onto the array map number. This is not loading the tiles into the game just yet. This is the method that's going to help load the tiles into the game. So we have some initial values, column, row, X, Y, and then the list number is going to be 0. So we have the while loop right here, and it's going to iterate through the map numbers tile, and then it's going to put this as each value is going to be sent to this variable called tile number, right? So it's going to read these numbers. The load tile is going to read these numbers, going to put into the map number. So the numbers that are going to be in this array are either going to be 0, 1, or 2. So we have the if else blocks right here for the tile numbers. So if tile number is 1, then you for the list you want to put a new tile. Um, that's going to be for number one. This is going to be wall brick. With the ID of one. Else, if the tile number in the map number to the array is two, we do the same thing, but instead we get the health pack. Let me check. Did I put it? Okay, so these booleans are for the collision detection. This is for like the solid. So wall break is going to be a solid, so it's gonna have collision. It's gonna have collision with the tanks and the bullets. The health pack isn't really gonna have uh collision. If it did have collision, then it would kind of be troublesome to move past the health packs, even when our our player tank is full of health. So we don't want to implement collision detection on that. There is logic for when the player tank comes into contact with the health pack. But how would I want to say it? There is logic for the player and the health pack once they collide, I guess. But that only happens when the player is only low on health, and obviously that's to recover health when you make contact with the health pack. If not, then we just make an empty tile. Um, the empty tile is not gonna be solid. It's just gonna be pretty much an empty space in the map. So right here we increment the value for the column to so we could just be able to again traverse to each and every individual tile and just set the tiles depending on what the tile number is. Um, this right here, this little line of code. So this is for basically. Let me just start the game real quick. So basically, the X is going to be starting from all the way in this little corner. But for us to move on to the next tile, we have to increment that X by the scale tile size. We have to do that. Or else there's going to be some overlapping on the tiles, and that's going to be having a very undesirable effect, visual effect on the game. So, so if the column does get to the max column amount, we reset the column and the X to 0, we increment the row, and Y right here. So, pretty much, let me just run the game again. It's pretty much going to be the same as what we was talking about with this, starting right over here. So, every time we traverse through the columns, it will go to the next tile size according to X, and then the next one. But for that line of code, we're gonna go down instead. So we're gonna be here, we're gonna be here. And again, if it's not without this line, there's gonna be a lot of overlapping with the tiles. So just avoid that. The list number. So once the tile has been loaded up, we just increment the index for the list number. So we could be able to get ready to load the other tile that comes after. And then we have some draw methods right here to help draw the tiles. I'm not gonna get too much into detail with this method, but I do want to explain the logic behind it. So pretty much the same logic as like iterating through the create tiles, but this time instead of creating the tiles, we're going to draw the tiles in accordance to the location of the tiles. So if tile number is 1, I gotta take this code off. We're gonna draw the image of the tile. Draw the image of the tile. That's gonna be tile list. We're gonna draw the image right here from this individual tile that's listed with the index, the list number from the tile list array, X, Y, size of the tiles, no. Same thing for if the tile is number two. This is gonna load up the wall brick. This right here is going to load up the health pack. Um, and then pretty much the same logic as the one as from the create tile method. Just to iterate through each tile, column by column, and then we go descend down to the next row after all the tiles in a row has been complete. So that's the tile map. This is to help load the tiles onto the map. Excuse me. So let me see. We're pretty much done with this. So next line of code right here. I have the string array for the poses. This is for all of the tanks from when they move in certain directions. If they move up, this is gonna be for like setting the images. Go into the resources real quick. Let me just go back to this. So I'm going to the sprite. So these are all the sprites that are going to be used for the tanks. Um, I have two different images here for the sprite in each direction, mainly because when you move, you can see the tracks moving. I'm pressing left and right at the same time to show how the animation goes. There's some animation to the tanks, um, and then I have the images for the bullets and when they're going in like certain directions, depending on the direction of that the tank is facing. So if the tank is facing up, the bullet's gonna go up. Down, bullet down, left and right, and so on and so forth. So this is all of the resources that I use for the sprites on in this folder, sprites. So this is going to the images for the sprites are going to load up in accordance with the pose. And right here, so I made a class for the sprite that inherits from the rectangle class. So as you can see right here, this is going to load up um the tanks from the resources folder. Let me just go into the sprite class real quick. Excuse me. So right here. So for the sprite class, again, it inherits from the rect class. I made this class called animation, right here. So basically, this is going to be like a array of images. This is pretty much just gonna be like the images that are going to pop up when a certain animation happens. Um, the current that's gonna be the ID for the specific frame in the animation, and then I included some variables called duration and delay. We talked about we talked about this in class. So animation. This is going to the constructor is going to require to name the count, like how many frames is going to be in the animation and the duration between the frames. Again, loading up the image in the track catch. Let me see. So we initialize the image with the initial count. So let me see. We have the method for the get static image. That's gonna be for when the tanks are not moving. That's gonna be the image that's gonna be set for when the tanks are not moving. Obviously, when they're not moving, and no animation happens, so you just get the static image for it. The current image method, the get current image getter method, that's for when the tanks are moving. That's when animation is going to be applied. So delay. Let me see. All right. So basically, depending on the delay and duration of the animation, this is kind of to change the ID for the current image. So after that duration completes, then we change the current image to, like, let's say 1 or 2. So right here, the current image, this is going to return the current image from the index that is set to current, whether it be 0 or 1. Um, so I wanted to kind of get back to here to kind of like explain this better. So um, if the animation, let's say for example, the animation requires like 3 images for the animation, for the full animation, this would be, let's say, an image size that's a array size of 3. Or if the animation requires, like, let's say 7 images, then it's going to be an array a size of 7 elements. So that's the animation. This is going to handle all of the changing the images whilst a certain animation is happening due to a certain action. Um, so the bullet class. This is a very interesting class. I made it specifically for creating the bullets. Just give me 1 second. Some water. Okay, so bullet just like the sprite class. It inherits from the rectangle class. Um, Pretty much the same thing. I do have an array of for the tank directions. This is pretty much the direction of the tank. So wherever the tank is facing is going to be the direction that the bullet is going to travel to. I have the variable for speed, the distance that it travels. This is like after firing. This calculates the current distance that is traversed. Max distance. This is the variable that determines the maximum distance that the bullet goes. In the game, the bullet is not gonna go travel on endlessly. After it fires, it's going to be set at a certain distance. After it fires, and then after that max distance is completed, then you could be able to shoot another bullet. Um, so that way you don't create an endless amount of bullets 60 times per second. There's a limit to how many bullets you can fire depending on certain situations. We have the integer for the direction, and then we have this boolean for if the bullet is a live bullet. Now, when you fire it, the bullet is going to be live. The times that the bullet is not going to be live is whether it collides with another object, albeit a tile or a tank, or when it's reached the max distance. That's when the bullet is gonna be dead. Um, so we have the constructor for the bullet right here. We have the bullet to be set. So basically, this is going to be called when we when we fire the bullet, when we before we fire the bullet. So what it does is it sets the image of the bullet depending on the direction of the tank, and it will be ready for when before the player presses F. Sets the direction, sets the image, and then once you press F, the image is going to pop out like that. So this is the move the move method for the bullet. I had to override it a little bit. So right here, this is depending on the direction. So if it goes, let's say, let me see. So if the wait, uh, okay. So if this goes up, then y will travel negative of the speed. In terms of the J frame, it will go up. Case one, which is down, it will go the opposite way. So it would go downward. And then right here, this would go left, x minus equals speed, and right, x greater equals speed. So it's going to increment once after firing the bullet. And then the distance is also going to increment in relative to the speed. So if for the bullet, if the distance is greater than max distance, then we reset the bullet. We reset it to have it back into the tank pre-fire. Reset. We turn the physics off for the bullet. This is coming from the rec class. This is pretty much um, taking away from this logic and just resetting it. The bullet is going to be set to false. It's not a live bullet yet. It's going to be ready though. It will be ready for fire if it's dead. But once it's live, you can't fire another bullet again until the bullet that's already out there dies. And then this is going to be set to 0. Draw method for the bullet. Just draw my image. It's going to get the image from here. So that's the bullet class. Now back into the spray. So right here, for the fall, we have the health of the sprite set to 100. That's for the fall. I'm gonna get into more detail on that later. And we have the boolean for the sprite being alive, and obviously when the level starts, everybody's starting out alive. Obviously when the sprite's health goes down, it's gonna be set to false. Let me see. So again, we have area elements for the directions. This is more so for the animation. We are going to initialize the pose to right for just default. Okay. So right now, sprites are not going to be moving as of now until it decides to move again. Let me see. Movement counter, we have it set to 0. Let me see. For the movement counter, that's going to be okay. We'll get into detail with the movement counter. So basically, what it is it pretty much increments every time like the game loop progresses, and once it gets to a certain amount, then this is I'm gonna go into detail into these two variables because these is for the AI. This is for the AI right here. This is the constructor for the sprite. We have the name, the pose for the array, and the image count. In this case is gonna be 2. It's only 2 images per animation for the tanks. um, so right here we call the super constructor for the rectangle class. Now this right here is the logic to pretty much quote unquote load the bullet into the tank. So we instantiate the bullet class, the bullet object. We set it to a new bullet. Um, this right here. Let me see. Is that the speed for the bullet. No, that's the distance for the bullet. Yeah, yeah. So this is the distance, 192 pixels. The speed is going to be 10, and then the direction of the bullet is going to be dependent on the direction of the tank. And then we set the bullet. So I wanted to get into detail with this line specifically because if we have the bullet set to the initial X and Y coordinates of the tank, then the firing process is going to look very, very weird. It's going to look like the bullet is going to fire from the side of the tank instead of like directly from the center where the cannon is. So I have this little line of code right here, and I had to look this up online to see how I could be able to center two squares together, given that one of the corners is a X and Y coordinate. Um, so I had to fish for a little formula online. So basically, what this line does is it sets the bullet directly at the center of the tank. It's gonna have it set at the tank, center of the tank when it fires. It's gonna start out from the center of the tank. Okay, and then we have the animation array. Um, so basically, this is going to be post that link. So I'm assuming that's going to be this is gonna be four. There's gonna be four animations that are gonna happen. Animation going up, animation going down, animation going left, and animation going right. Oh, sorry. Let me get some more water real quick. Getting a lot of water. Okay. So right here, this for loop. This is going to load the images so it could be ready for the animation once the tanks move. We're gonna override the draw method from rectangle class. So basically, this this is what's gonna happen. If the tank is not moving, then um, the animation is gonna get a static image for the animation, and once that happens, once the tank is not moving, no animation happens. The only time animation happens is when the tank is moving. In this case, the else. So right here, this is going to kick off the animation once movement starts happening. And this is like a bunch of code that I was experimenting with. But right here we have the image being drawn. Um, Depending on the length of the animation and the state of the animation and the direction. And then I had to override this directional methods from the rectangle class slightly. What I wanted to do was whenever you go a certain direction, the pose, not only the pose will change, but the moving variable is going to be set to true, and that's what's going to kick off the animation of the tank. And then we have the bullet fire method here. This is going to be tied to the tanks because the tank are the ones firing the bullets. So once that happens, the bullet is live, and again we set the bullet to be firing from the center of the tank. Um, and this is what I wanted to get into here for the AI for the tanks. So I implemented these methods to kind of like pretty much do what tank AI is supposed to do, and that's to shoot the player and move around. So I set this little method called in range, and basically what it does is it detects whether or not um, the enemy AI detects the player at firing range, basically. the max range is going to be 192, and that's pretty much the distance that the bullet can travel before it gets to before it dies. Um, so we can set the max range to 192 pixels. Um, so it's in range. This is going to return a boolean. If it's in range, it returns true. If not, it returns false. This is going to be these two methods are going to be needed for the AI to fire at the player. So right here, line of sight. This is a method that's used by the enemy AI to shoot the bullet when the player is in the line of sight. Now, um, thing is like before implementing this method, I implemented this one first, and what the tanks did was is that when it was in range, it started firing immediately, but it wasn't firing at the player. So what I did was pretty much let me see. So I have this thing called a view width, and let me just go into it's an image. Okay, so basically the view width, what it does is so let's say the mouse is the tank. Um, basically I'm moving around, but I'm not in the line of sight yet. This method helps with help the enemy tanks fire when I'm actually in the line of sight of the cannon. So like when I'm like here or even here or like directly in the middle, that's when the tank is going to fire. That's when the tank is going to fire. If I'm here, it's not gonna fire. If I'm here, it's not gonna fire. Only when I'm here is when the tank is going to fire. So let's get back. So this is what this method pretty much does. So I added some logic on here. So just to go into just one of the blocks for context. So if I'm up, so no. If the tank is looking up and the player tank is above the how do I call it? The player tank is above the said tank, um, and the range of X is less than or equal to the view width. So if it's in range of the view width, then you will return true, and then when that happens, the enemy tank starts firing, and it's pretty much the same thing for the other directions. If not, return false. Just have the AI tank just keep moving. Let me see. Okay. So this sets the initial direction for the wandering AI. This is when we load the levels. Um, right here I have the a wander method. So this is pretty much used to have randomly generated movement for the AI when the player is not detected. So so this is where the movement counter and the random move come into. So basically what happens is that let me see. What happens is every time like when a tank is moving, the movement counter is going to start to increase by the amount of milliseconds that yeah. It's moving up by the amount of milliseconds but in accordance to the game loop. The movement count is going to go up. This is going to help change the direction of the tank and help generate that random movement. Right here, once the movement count gets to a certain limit, we call a random class a random object, and we're going to set the random move to a random integer that's in between 0 to 100. And move count is going to be reset to 0. So random movement. So if the random movement is less than 24, if the random integer is set to 24, less than or equal to 24, tank is gonna go up. Or else if it's in this range from 24 to 49, 25 to 49, then it's gonna go down. If it gets into the range of 50 to 74, it's gonna go left. And then if it gets to the range of 75 to 99, then it's gonna go right. So that's what's gonna help generate that random movement for the enemy AI. And that's it for the sprite class. So right here, so what I did was essentiate the objects for the tanks. Um, right here is gonna help load the image of the tanks. This is gonna be a string that's gonna help with loading the images and animations and stuff. This is gonna be initial pose for the tanks. Got the initial coordinates set for the tanks to start out from each level. Let me see here. This is for okay. So basically, this is going to be set for to a scale tile size, but I decreased the dial size just so it can help with the collision detection when it comes to having to pass through narrow pathways. Because when I just left it at a scale tile size, it didn't pass through the narrow pathways, so I decreased it a little bit to 2 pixels. And as you can see here, we have the pretty much the specifications for each of the tanks. Tank 1 is power, more firepower. Tank 2 is speed, less health and power. And Tank 3 is armor, less speed and more health. The UI interface, I had to instantiate an object for this. Going to the UI. So this is the class that's going to implement the UI. It's going to take the game panel as a parameter. Going to take the class from the font. Essentially an object from the font. The display string, that's going to be the string that is going to be displaying on the UI once you get into either transitioning from game state to another. This thing is going to change. Initial string length is going to be 0. Options right here. This is an instructor that's more so for the options that you will select in the game. Right here, once you're once you either started the game or going or just finishing the game. So you guys select start game or quit. So I have a set to where if let me see. If I go up or down, that option, the number for the option is going to change and it's going to give me a different option. It's going to highlight a different option from the UI. I have the generic font set to Arial. Have it set to a certain font. So the method right here, pause text, is going to set the display screen to a pause. This is going to like when you press P and you get into the pause state, this is going to set the display string to pause. Level transition. So right here, this is going to display string level, space, and then the level number that is used as the parameter. So if I'm going to level 2, then it's going to say, okay, level 2. Once I finish level 1. And then when that, and change to 3 after level 2 and so on and so forth. Game over text. So I had to put an if else block in here. So if the player inside the game panel is dead, display string is going to say you lose. Or else, if you win if you win the game, if you're still alive, then display string will be you win in all caps. Health bar, I have some logic for the health bar right here. Set it up for the graphics. So the scale, I have the health bar representing the health, depending on the scale of the tile size, and then just divided by 100. So and then the bar amount is pretty much the health times the scale. Set it to red, and yeah, that's pretty much it for the health bars. But it is going to reflect on based on the player's health. So if I'm at a certain health, it's going to display my health in red right here. So this is going to fill the rectangle by depending on the bar amount. This is going to be depending on the health. Um, the rectangle below it is going to be a black rectangle, which is going to be pretty much the whole meter. Yeah. The timer. This was something that I wanted to implement for the group project, but we didn't get into that. And this is going to be the draw method for the UI. A lot of if statements right here. This is depending on the game state. So display the tile screen. This changes the game state to tile screen. Well, no, it doesn't change it. This is if the game state is a tile screen, then this is the UI that's going to be displayed on the screen for the title screen. New Middle City, certain fonts, got the color of the background showing. Title screen options. So this is start game right here. If the option is 0, again, this is going to change with the directions you input from the arrow key. It's gonna highlight the option yellow, and it's going to yeah, it's pretty much just gonna show the option highlighted. Quick game, same thing as a start game, except that if the option is 1, so you only get 2 options, 0 or 1 in the specific UI for the tile screen. Uh, Background for the in-game map is going to be white, but it's going to be under the image that we're going to call from the tile map. Display pause text. So if the game state is paused, display just the pause text in the level, just the black paused string on there. So we call the pause text method right here. Set the string to pause, and then have it display on the UI. So right here in the level change, level completion / failure. If it's a level change, then we transition to the level, and then we increment the level counter. I think the game is done. Excuse me. The secondary image, that's the image that pops up after right. That's no message. I'm getting all tangled up and stuff. So this is gonna be the string that's gonna pop up under the level, like level 2, level 3, level 4. This is gonna be the little personal message. Let's rock. And right here, if the game state is game over, add logic for win or loss. Right here, we set the game over text in all caps. Whether it be you win or you lose, depending on the logic. Right here, and then we're gonna have it set to the same. We're gonna have the same options for that screen as well. Right here, back to title screen, this and that. If the option is 0, then you go back to the title screen, stated here. Um, if it's set to 1, then you quit the game and it's gonna close the game. So that's the UI. It's a lot of code on there. Okay, so let me see. So we have the booleans for the keys. If they're pressed, if they're not pressed. Enemy speed set is set to 2 by default, but for in the case of the speed tank, I have it set it to times 2 to make it twice as fast as the other tanks in the game. I could have set it to an amount lower, but I kind of wanted to present the game a little bit like more challenging, so I just have the the speed tank just going all over the place. So this right here is the game panel. Pretty much this is gonna set the size of the game panel before we inject it into the J-frame. Screen width, screen height, same thing right here. Since the background is gonna be set to white, kind of redundant because we already did that in the UI. Double buffer. What it does. This is gonna reduce flickering, so we can have a smoother animation in the game panel. And I guess that's pretty much the reason why a lot of my classmates decided to go with the J frame is to just keep the buffering is like simple, just to reduce the flickering for the animation. And now we're gonna get into the beautiful part. We have the init method right here. So this is gonna initialize the game state to the title screen. Set the velocity of the player to 0 for both directions. We're gonna set directions right here to face right and have it set to 0 when it's not moving. Um, Let me see. Oh no, wait a minute. This is supposed to be, yeah, this is supposed to be the thing. I gotta edit. I'm already finding errors in the code already. So yeah, this is supposed to be for the different this is supposed to be for different. Yeah, now we got it better. I can't believe I have truly overlooked this, but eh. Excuse me. Minor changes. Add the key listener for the inputs. Request focus. For when the player clicks on the window to request a focus. This is gonna initialize a new thread and start the thread. It's gonna be all in this init method. So this is going to be the game loop right here. While true, this is gonna keep the game loop running. Let me just get me some water real quick. Okay, my apologies. Just had to, I guess, have to drink real quick. All right, going into the game loop. This is where all of the game logic is going to be in. Just a disclaimer. A lot of this code is going to look very similar. I wanted to make all of this logic a little bit more modular. Just put it into methods and stuff, but just in the essence of time and just me not being able to have as much time to put into the project for this semester specifically. I was thinking about 3 courses, but all of them were just like high level courses that I had to put in a lot of work and stuff. So I didn't really have much time to like put additional things into the game, um, as well as do some housekeeping in the game for the code, um, as well. But other than that, we're here. The game is functional. But there's going to be some repetitiveness, and it could have been a little bit more modular. But moving on. So we have all of these F blocks right here for the state of the game. So if the game state is title screen, this is going to initialize the tanks being live. Excuse me. Right here, once you get to the title screen. So, like, if you go into the game over screen, but you go back into the title screen, this is going to set these back to being alive. Once we get into the playing state, now this right here is going to determine the level completion or level failure. So right here, um, if player is not alive, or let me see, if the player is not alive, or the level counter is greater than 4, game state right here is going to be game over. So basically, if you were to die or you get past level 4, that's the end of the game. If Um, all of the bad guys are dead, but the level counter is greater than or equal to 4. The level counter is going to increment. This is going to help out with the UI as well. And then the game state is going to be the level change. That's where, yeah, the UI is going to pop up. I decided to go with a bird's eye view game, so pretty much took some logic from the lectures. Turn off the physics. This stops all of the sprites after the key has been released. Um, all of the tanks moving is going to be set to false. This stops the animation of the tanks. This is pretty much for user input right here. If up is pressed, player goes up, down, players go down, so on and so forth. This right here is the logic for shooting the bullets. Um, so if F is pressed and the player's bullet is not alive, the player could fire. This method is called is gonna fire the bullet. If let me see, and all this other if blocks are for the tanks. So basically, for one of these blocks, all these other blocks are the same. For one of these blocks is if the enemy tank has the player in its line of sight, and the tank is alive, and the tank is in range of is in firing range of between the player and itself, and the bullet for the tank is not alive. So I have it set to where the tank would stop moving when it's firing at the player, and then it will fire the bullet. Same thing for the second and third tanks. And then right here I said so when these directions are pressed for the player is allowed to move until you get to the next second of the game loop, and then this is gonna be called again, and then the player's just gonna stop moving. This is the same thing is gonna happen for the tanks as well. So this is the AI logic and attack logic. So for we could just go to talk about one of these blocks for the tanks. So for the first tank, if if the health is less than or equal to 0, it is dead and it is not moving. Now, if the player is in the line of sight of the tank and is not in range in firing range, if the player is not in firing range, what the tank will do is chase the the player. It would chase the player. This is coming from the rectangle class. Yep, it's coming from the rectangle class. So that's gonna be the logic that's gonna help the tank chase the player at the speed, obviously, at its set enemy speed. Else, if none of these are fulfilled, then it's just gonna wander around the map. It's just gonna wander around at a random movement. So right here, let me see. So if it's in the line of sight, if the player's in the line of sight of the tank and it's in range of the player, the physics is turned off. This is pretty much tying back to this logic, but just adding on the physics off for the tank so it won't move. Any other than that, it's gonna be set to move so it can move freely. Now, this is a little bit different in regards to like the speed tank and the armor tanks. So The enemy speed is going to be set to times 2. And it's going to be set to times 2. And the movement for the armor tank is going to be slow. So the enemy speed is going to be set to divided by 2. So it's going to go at the speed of 1. Now we're going to the bullet liveness after firing. So if this is pretty much the same line of code, just repeated 4 times for each tank. So if the bullet is alive for the player, if the player fires and it's live, then the bullet is gonna move. Pretty much the same thing for all the other tanks. This is under here. This is gonna be all the code for the collision detection. For the tanks and the tiles. So we're gonna run a for loop right here. This is going to traverse all of the tiles in the tile list that was set in the tile map object. So it's gonna iterate the entire list. So if the player overlaps the tile in the list, a certain tile in the list, and that tile is solid, then it's going to be pushed out of the tile. So it's not going to go past the tile, it's going to stay pushed out of the tile. Now for the health pack, if the player overlaps a certain tile in the list, but the tile is not solid, if the tile is not solid, but the ID of the tile list is 2, which is the health, which is the health pack tile. The ID for the health pack tile. If the ID is 2 and the player's health is lower than 100, this is just to make sure that the player doesn't get the health pack when it's full of health. The health pack just stays there in the game. Once the tank makes contact with it in full health. So basically, let me see. So this is going to replace the tile in that list with a new empty tile. This is going to replace a new tile in this with an empty tile, pretty much simulating like the disappearance of the health pack, just because the player already obtained the health pack. So if the player's health is less than or equal to 70%, the player's health is going to be plus 30. So you only get 30% health back for every health pack that you get. Else, if it's greater than 70, then you pretty much just set it to 100. We're gonna have to keep it at a limit of 100, because without this code, without this logic, if we just had this line of code right here, the player would have had like about 130 health, or in the case of 2 health packs, it would have had 160 health, and that's something that we don't want. We want to kind of like limit the amount of health that the player has throughout each level. And so this is a collision detection for the enemy tanks and solid tiles. So just talking about one line of code. If the tank overlaps a certain tile on the list and that tile happens to be solid, then just like the player is going to get pushed out of the tile. And the same thing for the other 2 tanks. So the bullets. This is for the collision section for the bullet and the solid tiles. So obviously, when the bullet comes in contact with like a wall, it collides with the wall and doesn't become a live bullet anymore. So if the player bullet overlaps the tile, if the bullet overlaps a certain tile on the list, and the tile is solid, and the player's bullet is a live bullet, the bullet is pushed out of the tile, and the bullet is not alive no more. The bullet's not alive no more. The bullet is dead. And this is pretty much the same just for the other tanks and their bullets. Player hit detection. So this is gonna be pretty much the same for the 3 tanks. So if the player's bullet overlaps the tank and it's a live bullet, and the enemy tank is alive. So collision is detected, is pushed out of the enemy tank. Enemy starts to lose 10% of health. Enemy loses 10% of health for each bullet, and the player's bullet becomes false. Becomes false. Let me see. Becomes false. Um, this is pretty much the same logic for Oh, just to go into detail a little bit. Um, if the bullet comes into contact with the speed tank loses 15 health instead of 10, because again, speed tank has less health. If the bullet comes in contact with the armor tank loses only 5% of the health. So you would have to pretty much shoot the tank, I think, like 20 times in order for it to die. The armor tank has more health, so it's only going to lose 5% of health. So that's the player hit detection for the bullet. Enemy hit detection. So right here, it's pretty much almost the same as the player hit detection. So right here, the bullet if the bullet from the enemy tank overlaps the player and it's a live bullet, collision detection right here, pushed out of player. The player's health goes down by, in this case, 20%, because this is right here. This is the power tank. Right here, this is the power tank, so more power in the bullets, and then the bullet becomes false. The liveness of the bullet is false. This is for the speed tank right here. In this case, player health goes down to 5%. The speed tank has less bullet power. Um, and pretty much for the fall from the armor tank, just 10%, pretty much the same as the amount of damage that the player can inflict onto the power tank. Yeah. So that's it for the bullets. So the individual tank collision detection. So right here, just one block of code just to talk about it. If the player overlaps an enemy tank and the enemy tank is alive, um, this is going to push the tank out of the enemy tank, and pretty much the same thing for the enemy tank as well. Um, in the case that the enemy tank dies, the enemy tank is going to disappear. However, the object is still going to be present, but I made it so that when it dies, not only the image of the tank disappears, but also just the collision detection for the enemy tank is gone. So where the enemy died at, and pretty much the object is going to stay there. However, the player can pretty much just go through that original position where the enemy tank died. So there's no collision detection there. The collision detection is only present when the tanks are alive. So pretty much the same thing for the other two tanks. And right here, same. It's gonna be the same line of code. Similar, except that this time I added in if both tanks are alive. Pretty much going back to what I just stated. So if the enemy tank goes to where and another enemy tank died, um, it could go through pretty much go through that object of the tank. I want to say it would go through the object of the tank. I want to say, but it's the no collision detection is going to be detected. This collision detection can only happen when both of the tanks are alive. If one of them is alive, no collision detection is going to happen, and yeah, whichever tank is dead is not the image of the tank is not going to be there. Just to kind of like make things simple. But yeah, both of them get pushed out. Pretty much the same thing. Just added another additional condition right here to make sure that no collision detection happens when one tank dies. So right here, I added some logic for ending the level when all enemies die or the player dies. So Let me see. No, this is just for the. Yeah, this is just for the player. I don't know why I wrote this. If the player's health is less than or equal to zero, player alive is set equal to false. So this is going into the this is the playing state. This is all the logic for the playing state right here. This is all the code that happens when you're playing the game in the level. So game state is paused. We're gonna have this line of code is redundant. This comment is redundant. It's not, but when the game state is paused, all of the tanks are not gonna be moving at the time. This is to ensure that that the game is indeed paused, and try to not have like any weird movement happening and having the tanks kill the player while the game is paused. Let me see. Right here, the game state. If the game state is a level change, this is going to present the UI for the transition of the levels. This is where we would want to reset the position and health of all of the sprites. So right here, just that additional conditional, if the level counter is 4, so if the game state does go into a level change, let's say for example, this is in the case of when the level change happens after level 4. So once the level counter goes over 4, game state is going to be immediately changed into a game over state. Okay, so it's going to immediately change into a game over state once the level counter has been reached over the 4. So level change, the game state of the level change is still going to happen, but it's going to immediately go into the game over game state. So right here, none of the tanks are moving. The health and the position of the player has been reset. Going on to the next level. All of this is all of the health and position of the tanks has been reset. And then they come back to being alive. Right here. The bullet aliveness is all set to false just to not have any bullets flying from the previous level onto the next level. That's something that I noticed while I was coding, that every time a level change happened, some bullets would be flying around from the previous level onto the next level. So I had to make sure I had to call these, I had to make these, implement these lines of code so none of that happens. And this is the code that's going to be used to change the tile map. Just give me 1 second. Okay. This is going to be the code for the tile map. Right here, the map. This is pretty much just going to be the tile map for a game panel. We call this method to change level. The level counter, this is going to be the number that's going to go into getting the file that has that number, the text file that has that number, so that it could be able to load the tile map in accordance to the text file and the numbers that are in the text file. And then once that happens, change the level, and then we go on ahead and recreate the tiles again. So that's how you could be able to see like the position of the walls changing and the positioning of the health packs changing as well. And yeah, so if the game state is game over, it's just pretty much the same thing as level change, you know, just pretty much just reset everything. Except this time we set the level counter to 1, just so we could be able to start from level 1. Reset everything, reset the positions, reset the health. Bullet aliveness is false again because of the issue of bullets from previous levels going on into the next level as well. Um, and then we pretty much implement the same block of code right here to help create the tiles, change the level and create the tiles in accordance to the level. And right here we repaint in the game loop. After, like, when things change in terms of like positioning, movement or whatever, is gonna help repaint those paintable resources onto the game. Um, we are gonna put a we're gonna let the thread sleep for about 15 milliseconds. Put in a try and catch, just in case if any errors happen. Um, so right here, in the case of applet, um, we applet had the paint method, but since we're using JPanel, we have to use a different method for the paint. When in this case, it's called paint component. That's pretty much the paint method for JPanel. It's pretty much the same thing as the paint, but just here, just game specific stuff. So if let's say, like, if the UI, if the game state is title screen, level change, or game over, where the UI is presented as some sort of like text and options presented before a level starts, or when the game finishes, we want to call the draw method of the interface to help draw out the UI. If not, if it's in playing state or pause state, we just we draw the map, we draw the interface of the health bar, we draw the timer for the interface into the game. We draw the player if any of these enemy tanks are alive, they get drawn into the game as well. This was going back to where if this thing concerning the collision detection, it doesn't involve it doesn't make any changes to collision detection, but it just pretty much helps visualize that, okay, you killed the tank is not going to be there anymore for you to deal with. So if they're alive, draw them into the game. Same thing with the bullets. If the bullets are live bullets, draw them. Draw the bullets. If the bullets are alive and the tanks are alive, also draw the bullets for the enemy tanks as well. And then we pretty much draw the UI for the in game, for whether we're playing the game or the game state is set to pause. We draw the interface for that. And this right here. This is the method that I'm calling to make sure that I'm moving my player and it shows the change in coordinates. So this is a little log in a console that's been implemented. Excuse me. Okay. So right here, this is the key listener. In the key listener, key pressed, this is going to involve additional logic in terms of the state of the game. So we have the get key code is going to get the code for the key that's being pressed. So if the game state is title screen, so basically what we would want to do, we would want to have the player navigate through the options. So this is not to move the tank, this is just to simply select the option 0 or option 1. That's what the this thing is this logic is used for. So basically it would just be you know so we have it to where right here, if you're going up while you're selecting the option decrements. But if it gets decremented past 0, then it's gonna reset to 1. So if I restart the game, so if I press up right now, it's gonna go to quit instead of just not moving, because it's gonna make some weird errors. in the thing. So I just have it to where like it just goes back to a quit when I press up, or also in the case when I press down on quit, it gets back to start game. But when I press down on start game, it goes to quit, and go up, it goes to start game. Just regular stuff. But this is just kind of like having to choose in between two options every time you press up or down. And this is pretty much the same thing as this piece of code right here. Um, for enter, so if the option is 0, in this case start game, when you press enter, it switches the game state over to playing. Um, if the option is 1, then system exit, you leave the game and it closes the JFrame. Else, if the game state is game over, this is pretty much the same thing. So you know when the game over screen pops up, you have two options, whether you go back to the title screen or to quit. This is pretty much the same thing. So if you go to back to title screen, it's going to take you to the title screen. If you quit, then it's going to close out the game. If the game state is a level change, there's not really any options. It's just a transition. The UI just prints out the transition. So just sorry. So pretty much the game state will be playing game state. And interface option is going to be set to 0 for the next interface if you win or lose the game. But to switch over to the playing game state while you're at the screen for the level change, you will have to press enter to proceed to the next level. And this right here, this is for pretty much the code that's gonna be used for for the gameplay. Right here, this is the pause button. The logic for the pause button. If the goal is P, if you're playing and you press P, the game state is going to be switched to pause. If it's pause, then it's going to be switched back to playing. And right here, we just have the key released and the key listeners for for the for the controls. And that's pretty much it for this project. For the code, um, you know, it's pretty long, and again, I could have made it modular because there is a lot of repetition with the code. I just haven't had the time to do housekeeping during the semester because these classes have been taking up a lot of my time, and I also work full time too, so I haven't really been able to get as much time to put onto the project after the semester as I wanted to. But I did get like about like I want to say 98% of the code done before the semester ended, so just took a little bit of time that I had left to finish the rest of the two and just make the game functional. Um, so far, I had about two classmates test the game out for me. I even had family members test the game out for me as well. They said the game is running very very well, and that they liked how the game was and how challenging it was for them as well. And I had just had a positive feedback overall. Um, so I pretty much, since I wasn't really using as much resources in the game, I pretty much just put all of the sprites and the tile images onto the source code instead of just making a separate resource file. Um, do have the text files for the levels right here and pretty much everything else. Just for the sake of it, just run it one more time and just try to play the game right here. Yep. So this is pretty much the game. Kill him. Um, right here. And then we're going to level 2. Ooh. Alright. That was a smart call by me. I would have died right there. So we got the health back, we gotta have Go here, get another health pack, get some more health. Let me just take care of this tank right here. Okay. I also kind of wanted to make the AI for the enemies a little bit better, so I can have a smarter decision making. But again, for the essence of time, it was just yeah, just kind of kept it as it is. I mean, how the logic goes for how they fire is already working well. Um, not lost. But yeah, just this is Mew Metal City. This is my solo project for CMP 428. I hope you had the chance to play it, and I hope you like it. But yeah, this is pretty much it for the project. It is a lengthy video, but I do appreciate the time that you had to view everything and all this other stuff. But yeah, I hope you like the game. And yeah, uh, hope you play the game. If any review you want to throw out, just let me know, and I'll read it at some point in time. But yeah, again, I hope you enjoy the game. And that's it. Till next time. Bye.